Hi everyone, today I'm going to show you how to make this Raspberry Pi robot that I designed and built at home. We're also going to learn all the programming that I did so that it can move and how I put it together. First, let's learn all the components we need. First, we need some batteries. 4 AA batteries is what I used, and these are rechargeable so I can charge them whenever I want. After this, you'll need something to put all your wires together, so I used a breadboard. This is a pretty large breadboard, so you won't need something this big. You can just use a smaller breadboard that's half this size. You also want it to have double-side stick tape like I have on the back so that you can mount it onto your chassis. After this, you'll also need some servo motors. So these are motors that have servos attached to them. You can find these for a pretty cheap price on Amazon. They also have wheels and tires so that you can attach it to your robot. The next item you'll need is your Raspberry Pi itself. During this demo, I'm going to be using this clear Raspberry Pi case to represent my Raspberry Pi. After this, you'll also need a battery case like this one. It can hold 4 AA batteries, and it also has a switch. Using this switch is really convenient, so you can turn on your robot whenever you want. This will be powering your main motors. Next, you'll need a glue gun. Now I have this hot glue gun, it's a mini hot glue gun, and it helps to put things together. You don't need it, but it's helpful to have. I used a pretty interesting building material to build my chassis. Here's some Lego bricks. You also need some more to build other stuff during the building process. This here is the L29 3D motor driver. We'll use this to control our motors, and it hooks up to your Raspberry Pi. Next up, we'll need a bunch of wires. Here I have some male-female jumper wires that you'll need, and after that, you'll also need some male-male jumper wires. A few more of these than the other ones. After this, you need some electrical tape. This is pretty cheap, and you can find it at a hardware store or on Amazon. Next, we'll need something to power our Raspberry Pi. Here I have a mini power bank that I got off of Amazon. It was pretty cheap and it works pretty well. After this, I also have a Pi switch. The Pi switch is included with the Raspberry Pi, and it helps to turn my Raspberry Pi on and off without pulling out the cord every time. Next, we'll need something to help our 2 motors move around. Since there's only 2, it's a balancing issue. This metal ball bearing that's inserted into a plastic holder helps to keep the Raspberry Pi robot in balance. I mentioned earlier that I'm using a mini power bank to power my Raspberry Pi. But if you want to power your Raspberry Pi with the main power supply, you can also use one of these voltage buck converters. They're pretty cheap, and you can use this instead of getting a separate power bank. Here's an image of all of the things that you'll need to build the robot. Now we'll start building the chassis. I'm using 2 half plates here, and I'm using 2 strips of long Lego that I'll use to connect both of these big base plates together. Using these 2x14 strips, I can make space in the middle so that the wires for the motor can come through. You want to connect your Lego strips about 4 studs deep into your base plates. After you do this, just connect up your second base plate to the first one, and you'll have the completed base chassis. Now, after you're finished building your chassis, let's add the ball bearing. Here, I just hot glued the ball bearing onto 3 2x2 Lego bricks. You can see here that it can move around pretty freely and that it's stuck on there. So you can take it off whenever you want though, so that's the good thing about Legos. After you've completed the step of adding your ball bearing, let's move on to the motors. You can see here we're using the 2 servo motors that I showed earlier. Now, these guys have 2 metal strips that you can attach wires onto. I soldered my wires onto my motors. These motors will go onto the pink strips of our Lego chassis. I got the wires to solder onto them from random electrical pieces that I found around the house. You want to put your motors a little back from the center. You don't want your tires to be too centered because your ball bearing will gain more support if the motors are in the back. Now simply hot glue on your motors, of course after you've soldered on your wires and you're ready to go. After you've finished completing the bottom part of the chassis, next we'll go on to the top part. On the top, you want to place your Raspberry Pi and all of the other main components of your robot. First, you want to put your breadboard. Since I'm using a really big breadboard, it fits perfectly on the side of the chassis like this. You can use the same idea, but if you have a smaller chassis, you can probably fit it on one side. To attach the breadboard on, just simply peel back the double-side stick tape and stick it on. Now, let's add on the big power bank. Now, this power bank here, I double-side stuck a small Lego base plate on the back, and we're going to put it about to the left of the breadboard here. I also used 2 other small Lego bricks that you can see here, just 1x4 brick pieces, and I can stick them on the base plate like this. Using this method, I can simply just stick my power bank onto the Lego chassis, and whenever I want to charge it, I can just take it off. During the process of putting my power bank on the chassis, I noticed that the Pi switch has a really long cord. We want this to be a little smaller so that it doesn't interfere with the motors. So I decided to just wrap it around the power bank like this, and it should make it a little smaller. Here I could just fit it around my power bank like this, and then plug it into my Pi later. Now for the Raspberry Pi itself. Here, this Raspberry Pi will be, of course, on the final space of the chassis, and you want to plug in your Pi switch to the Raspberry Pi. However, you also want to place your Raspberry Pi so that it's convenient. Here you can see on the finished robot, I placed the Raspberry Pi so that the USB and the HDMI cords are out, so that I can plug it into my monitor whenever I need. Now for the battery pack. Here's the battery pack that I'm using with 4 AA batteries, and I can just plop them in like this. Now, after you finish putting the cap onto your battery pack, we can mount it onto our chassis. When mounting, we want to be really careful so that the switch is showing out. When the switch is out, we can actually operate it. Now, we want to mount our battery pack on the underside of the chassis. So let's take off all of our demo stuff and put it on the back. Now that we flipped it over, we want to just put some double-side stick tape on one of the sides of the battery pack and just stick it on to the chassis. And remember, you always want your switch to be showing so that you can operate it. Including your switch, you also want your wires to be easily accessible. After you've mounted everything onto your chassis, plug in your Pi switch to your Raspberry Pi. Now it's time for the wires. You want to put your wires onto your Raspberry Pi's GPIO pins and then plug them into your breadboard. Next comes the L29 3D motor driver module. We're going to be putting it onto our breadboard at the end so that we can get enough space to put all the wires. Next, the final step is to do the wiring. Here on the finished robot, you can see I already did all the wiring. I'll be showing all the wiring steps in little snippets from a book called Learn Robotics with Raspberry Pi by Matt Timmons Brown. Here you can see the comparison between the finished robot's chassis and the chassis that I'm holding right here. It's completely filled and loaded with all of the components. Here's the first snippet from the book. You can see the outer wiring here with the buck converter. You can completely ignore that if you're not using a buck converter. Now onto the first steps. Here, the battery pack should be connected to the negative and the positive rails on the opposite side of the Raspberry Pi. On the bottom here, the black wire is connected to both of the negative power rails. Next, you want your Pi's pins that are pictured here to be connected to the positive and negative power rails. Next, you want to connect both of your negative power rails on the both sides to the middle parts of your L29 3D module. You can see here they're both connected to the middle pins of the L29 3D. Now you want to add on the red and white wires that are connecting the positive power rails onto the ends of the L29 3D. Next, you want to connect your actual motors to the L29 3D. Notice that these motors have wires extending from the bottom to the top. You want your motor's wires to extend through the middle, the gap that we made with the chassis. Now you want to add on these purple wires that are pictured here. You want them to connect your Pi's GPIO pins to the pins pictured here on the L29 3D. Now you want to add these final dark pink pins, and these ones are going to be connecting to the other side of the L29 3D from the specific points of the GPIO pins. Now that we've finished building our Pi robot, let's start putting some life into it. Now that we've finished building it, we can start programming it. This is the Wii remote. We can use it to move our robot around. Wii remotes are pretty cheap online, but you should always buy the actual Wii remote, no third-party stuff. After this, let's open up the back and put in the 2 AA batteries that are required. Our Wii remote is going to let us control our robot with ease. Now it's time to start programming. To program your Raspberry Pi from a distance without using any cords, we need to download a software called Putty. Putty is a free SSH software that we can use to program our Pi without having to plug stuff in. After this, you want to go to the link on the first website that you find about Putty and download the software. After the software is downloaded, you should be able to search Putty and get it onto your device. As you can see here, it's asking for the host name or IP address. The next step is to find out your Raspberry Pi's IP address. We can find this in many ways, but I'll show you the simplest. Also, You'll need to enable SSH on your Raspberry Pi. I ran into this problem pretty early and it took a long time to figure out. So go into your Raspberry Pi's preferences and change the SSH to on. Here I'm entering in my IP address. As you can see, I have already found it out. Now let's move on to how to find your IP address. Plug in your Raspberry Pi to a monitor. After you've done that, go into the terminal. Here you can see a black screen with the command prompt. Type in ifconfig. This will allow you to see your IP address number pretty easily. After you've hit it, you'll see a bunch of text. You want to go down to the area that says WLAN0. And then in that paragraph, you want to go to iNet. The number next to iNet is your IP address. As you can see, 10.0.0.93 is mine. And that's what I can enter into PuTTY to control my Raspberry Pi remotely. Now that you got your IP address, let's enter it in and start the program. After you've entered into PuTTY, you want SSH to be enabled and you want the port to be 22. Hit enter and you should see this screen. You should log in as the default username, which is Pi. After you've hit that, it'll ask for the password. And the default password, if you haven't changed it, is just Raspberry. It won't type in the letters for you, so you just have to hit Raspberry and enter. Afterwards, you should see a bunch of text. At the end, you should see the command prompt, just like the one on your Raspberry Pi. This is where we can code. Now, let's start coding. First things first, we want to actually make the code. So, let's do that first. On our Raspberry Pi, you can see this is the code that I wrote for our Wii Remote controlling program. But the first thing you want to do before this is download the packages for Seaweed on GitHub. That's a program that allows us to control the Wii Remote. So the first two lines of code here, I imported the GPIO 0 pins and the Seaweed program. Next, I told the Raspberry Pi which pins are controlling the motors. If you wired it up correctly, it should be 17 and 18 for the left motor and 27 and 22 for the right one. After that, it'll print the message, press and hold the 1+2 buttons on your Wii Remote simultaneously. This will start the Wii Bluetooth handshake process and allow you to control your Raspberry Pi robot with your Bluetooth-enabled Wii Remote. After the Wii Remote will connect, you can print connections established, and this will allow you to start the rest of the process. Now we want to enable the Wii Remote to the Seaweed so that we can start programming our actual Wii Remote. Under this, you'll see a while loop, and there you'll have a bunch of if statements. There, it contains all of the different buttons and what they'll do. For example, if you hit the left button on the Wii Remote, the robot will go left, and so on. Also, you should note that the B button, or the button that's on the back of the Wii Remote, is the button that will brake the robot. That's what you use to stop the motors and stop the robot. All of this code will be copy and pasted into the description, so don't worry, you can easily access it. After you've finished writing your code, you can go into the folder that you saved your code into. I saved it into the directory called robot. Now to start the actual code, we can type in the name of the folder and Python 3 before it. This will run our folder in Python 3. Now you can see that it prints press and hold the 1+2 buttons. So hold those two buttons on your Wii Remote as quickly as possible. After this, it should say connection established and your Wii Remote is ready. After you've finished this, remember to unplug all the cords from your Raspberry Pi and then turn on your battery pack so that your motors are on, as you can see here. And after everything's ready, you can begin moving your robot. So you can see here I put it on a hardwood floor so that it's easy to move, and here's how it moves around. Well, that's the end of the video. But you can see here I got most of the ideas from this Learn Robotics with Raspberry Pi book. You can find this book on Amazon, so please buy it. It's pretty good. Also, the guy that wrote this book, the Raspberry Pi guy, has a YouTube channel. Go check that out as well. Thanks, and bye. Also, if you're interested in these kinds of videos, I'm going to be adding different modules to my Raspberry Pi robot to make it even better. So, you can check these out as well.